All right, let's get right into it. We're about to unpack a philosophical question that's been around for literally thousands of years. But it all starts with something so simple, you've probably asked it yourself without even knowing it was a famous problem.
Okay, look at this. You've got two red apples. We call them both red. Easy enough, right? But here's the question. Is that redness a real thing they both share? Like a real ingredient that exists out there in the world? Or is red just a handy word, a label our brains came up with because they happen to look kind of similar? Is it real or is it just a name? That is the entire puzzle right there.
And this puzzle has a very grand name, the problem of universals. And it's a huge deal because it's asking about how reality itself is put together. Are the categories we use every single day, redness, humanity, even Apple, are they actual built-in features of the universe? Or are they just concepts we've invented in our own minds?
Now, for centuries, the greatest minds in history have basically split into two opposing teams to answer this. You can think of it like an epic philosophical showdown that's been going on for over 2,000 years. You've got Team Realist versus Team Nominalist.
And here are the battle lines. On one side, you've got Team Realist. They believe universals are absolutely real. Redness is a thing that exists out in the world, and reality has a pre-existing structure that we discover. But then, Team Nominalist shouts back, no way! They say universals are just names. We're the ones imposing structure on the world with our labels. For them, reality is just a giant collection of totally unique individual things.
Now, even on Team Realist, you've got a couple of star players with different game plans. First, there's Plato. He believed in a kind of cosmic blueprint. For him, the perfect, ultimate form of redness exists in some higher ideal realm, and all the red things we see are just flawed copies. But then, his student Aristotle brought things back down to earth. He saw it more like an internal stamp. The property of redness actually exists inside every single red object.
And here is Team Realist's absolute home run. They are fantastic at explaining objective truth, especially something like math. Think about it. The number 7 is prime. That's not an opinion. It's just a fact. It's true everywhere, for everyone, and it was true long before any human was around to think about it. That really feels like it points to a real existing structure in the universe.
But then, the Nominalists brought out their secret weapon. You've probably heard of it, Occam's razor, summed up in this quote by William of Ockham. It's basically the ultimate keep-it-simple rule. It says, hey, why are we inventing all this extra stuff? Do we really need to believe in some mystical realm of perfect forms or invisible properties? Let's just stick to what we can see. And this is where the Nominalists really shine. Their view is perfect for explaining the messy, real, physical world that science deals with. I mean, a biologist isn't out there studying some abstract, perfect form of the tiger. No, she's studying this specific tiger with its unique stripes and its particular history. Science is all about individual things, and our categories are just the useful tools we create to make sense of it all. It just feels so much more modern.
So what we end up with are these two incredibly powerful, compelling theories, but each one has a massive blind spot. And for centuries, this has been a complete intellectual stalemate. Neither team could ever land that knockout punch.
This little scorecard just says it all, doesn't it? Realism absolutely crushes it with the clean, objective truths of math and logic, but it kind of fumbles when it comes to the messy, real world. And nominalism? It's the complete opposite. It perfectly describes that messy, physical world of science, but has a really hard time explaining why math seems to be objectively true and not just some game we made up. You see the problem? Each theory's greatest strength is the other's biggest weakness.
So how in the world do you break a deadlock that's lasted for millennia? Well, the source material for this explainer puts forward this just brilliant solution. It's not about finding a lazy compromise in the middle. It's about completely reframing the fight. It suggests that we've been trying to use one single tool for two very different jobs.
And here it is. The big idea is this: a partition of domains. Let's stop arguing about which team is right about everything, and instead let's ask a smarter question. Which team is right about which part of reality? This is the key that unlocks the whole thing. So how does this partition actually work? Okay, part 1. For the physical world, the world of atoms, planets, trees, animals, Team Nominalist gets the trophy. The world is just a collection of unique individuals. Our categories like species or mammal are incredibly useful tools that we as humans invent to create a map of that complex reality. The lines aren't already there in nature, we're the ones who draw them.
And this fits perfectly with how science works today.
But this is where it gets really cool. For the conceptual world, the world of ideas, of logic, of mathematics, Team Realist was right all along. These structures are real and they are objective. Think about it. We don't invent that 2 + 2 = 4, we discover it. The Pythagorean theorem is simply true. It was true before we were here, and it'll be true after we're gone. These are real features of an intelligible, conceptual world, not a physical one.
All right, so who cares? Why does this philosophical judo move actually matter in the real world? Because by splitting reality into these two domains, we suddenly start solving some of the biggest puzzles about science, knowledge, and how we understand the universe.
You know that famous mystery about the unreasonable effectiveness of math? Why is it so darn good at describing the physical universe? Well, this explains it. It's because the universe has real quantities and relationships that these real conceptual structures can map onto. This view also lets science have its useful but messy categories without needing to pretend there's some kind of perfect eternal forms. And it explains why people all over the world, across all of history, discover the exact same mathematical truth. They're all tapping into the same objective conceptual reality.
And this gives us this just beautiful, elegant new way of looking at what a scientific law even is. It's the meeting point. It's the place where these two worlds collide. You take a real objective structure from the conceptual world, an equation, and you realize, oh my gosh, this perfectly describes what's happening out there in the physical world of individual things.
And this quote from the source really just nails why this is all so important. This whole problem of universals, it was never just a word game. It was a deep cosmological question about the nature of creation itself. How do you even get a world full of separate, individual things in the first place?
So that leaves us with this one final provocative thought to chew on. The patterns and structures we see all around us in the cosmos, in nature, are they things we find or are they things we make? And the amazing answer this hybrid view gives us is both. We find the rigid, objective structures of logic and math, and then we use them to make the useful, flexible categories that help us understand the physical world. And thinking about that, well, that kind of changes everything.